Coming up, the plans to thicken the ice caps. When global warming meets mad science, can we really geoengineer an end to climate change? Hi everyone, Neil Patterson back in the Sky News Daily Studio, where we have some rather out-there science to discuss today. No doubt many of you will have heard of the melting of the polar ice caps. I imagine some of you will no doubt be sick of hearing about it. But it is a major problem. And the scientific consensus has long been it's climate change that's responsible. Which means, of course, we are responsible, not just for the disappearing ice, but all the things that leads to, most obviously, rising sea levels. Up till now, we've been dealing with climate change through decarbonising our economy. Think electric cars, renewable energy and so on. But Sky News has been to see a group of scientists who think they can geoengineer the ice back to where it belongs. Thomas Moore is our science correspondent. Thomas, how about you begin by explaining exactly what geoengineering is?
In effect, you are engineering the planet or repairing the climate is another way of seeing it. And what you're essentially trying to do is to reverse the effects of all the sun's warmth coming and hitting the Earth now, the greenhouse effect, trapping all that warmth beneath that layer of carbon dioxide. So you can either reflect sunlight back out into space, or you can try and mitigate the effects of all that sunlight. So you might think about the warm water, which is lapping against the ice in the Arctic and the Antarctic now, and accelerating that melt. But you're trying to preserve that polar ice for as long as possible because it is crucial to cooling the planet.
I can see why this might be quite attractive to some because, of course, what it doesn't involve is us reducing our carbon.
Well, as we found, reducing carbon is really hard. We've been reliant on fossil fuels and all those emissions for so long, and it has taken us a long while to reduce that. Very successfully now, but nowhere near at the pace that scientists would recommend. Reaching net zero by 2050, they believe, is the way that we're going to stabilise the climate, and there's urgency and scale that's required. So if there is this idea of an easy fix, go and save the Arctic and the Antarctic because they are so vulnerable, then perhaps that is attractive to some people.
OK, Thomas, time for the science bit. I mean, how do we do these things? You've been to Cambridge, to something known as a specialist climate repair unit.
It's basically a container which is kept at -9 inside a lab.
Okay.
And it is pretty cold, as you would expect, because they are trying to recreate the conditions in the Arctic. So you go through a double door hatch to get inside, to try and keep the cold in. And they're basically trying to recreate in a bucket, in simple terms, how sea ice freezes. And they're monitoring that very carefully with a series of probes so they can track what happens. And then once that has frozen, they pour water on top to see how that then reacts in the cold environment that would be in the Arctic.
I'm going to go out on a limb here and say if you pour water on ice, in a cold room, it's probably going to freeze.
It is going to freeze, but remember, in the Arctic, what they're doing is pumping seawater, salty seawater. And when winter comes around here, they're spreading salt on the roads to stop it freezing. Mm-hmm. So there is this concern that if you're putting a lot of salty water on top of the ice, that you might have unpredictable effects, that salt might change the way the ice melts the following summer. But the evidence so far suggests that the salt actually, almost like percolates through the ice, goes back down into the water. So the ice becomes fresh, right? And it becomes more resilient through this process potentially, and that might stop it melting. And this is the idea. If you can stop ice melting the following summer, if you've built up that layer of ice so it's so thick it remains covering the dark Arctic Ocean, then less heat will be absorbed from the sun. It's reflecting more sunlight back out into space. And that's why they believe this is a great way of cooling the Arctic.
From your perspective, how successful have they been in that regard? I mean, it is one thing to carry out experiments on, as you say, basically a bucket in a cold storage unit.
Well, that's why they want to go to the Canadian Arctic this winter, and they're going to install 4 pumps over an area of 1 square kilometre on the sea ice, and they're going to test it. And they are going in with an open mind. Okay, so they're not saying this is going to fix the climate or fix the Arctic. They want to test this out there in the wild. And they say that you can't have an argument over geoengineering, does it work or is it just science fiction, without evidence. And that's what science does. It goes out there, it gets evidence, and then you can have an informed debate.
You're one of those rare people that has actually been to both poles. You've seen firsthand. What is specifically the issue globally with the polar ice caps losing their ice?
What happens at the poles affects us all. That is the message again and again I've been told by scientists who are studying both poles, because not only does the reflective white covering bounce back so much heat and light back into space, ice, particularly in Antarctica and Greenland, if that melts, then that has a direct impact on sea level. So if Greenland all melts, it becomes Greenland, you're talking about 7 meters of sea level rise. And if Antarctica goes, and that's a huge continent, that's 58 meters of extra sea level that we're going to see. Now think about the UK. Well, it would completely change the coastline. And even a rise of 0.5 meter, you're looking at 800 million people around the world being flooded from their homes. So 58 meters, just imagine.
But the scientific community is not universal in its support of this, are they?
Absolutely not, because it is so wild. The technology is untested, and they are very open about that. To scale it up to the level required be hugely expensive. So even this idea of putting pumps on the sea ice, they say you'd need 1 million to cover just 10% of the sea ice in the Arctic. And you need that many to make a measurable difference to reflecting sunlight away from the poles.
So what would it look like if we were to scale this up to the sort of area that we would need to really fundamentally tackle what's going on at the poles?
So the vision of these scientists at the Climate Repair Unit in Cambridge is that you'd make a hole in the ice. It would be about 12 inches across, and you'd put a tube and a robotic pump down into the water. It's not very deep, and that would, with a battery, it would constantly suck up water from the sea level, and you would flood the surface of the sea ice across quite a large area, because it's largely flat sea ice. So you could have quite a big effect from one pump. But you'd have 1 million of these, they reckon, across a very large area. And that would mean you'd be thickening up that layer of ice to make it more robust. There's more of it to melt and more of it left to cover the ocean in the summer, where we are seeing these extraordinary increasing temperatures. Climate change in the Arctic is happening 3 or even 4 times faster than the rest of the planet.
What is the current state, though, of the ice at the poles?
It's controversial. I mean, there has been some misinformation that there has been a pause in climate change. That's not the case. That is, if you look over the long term, there is a pretty constant trajectory of declining ice in the Arctic. And until recently, it had looked at the Antarctic was getting away with it. There hadn't been quite so much impact down there because it was much more isolated by the vastness of the Antarctic Ocean, the Southern Ocean that surrounds the continent. But we're seeing record declines in the ice shelves around Antarctica, and there is growing concern that you might see an acceleration of the warming in Antarctica in the coming years.
Isn't there something that we know works when it comes to climate change? The mantra has been decarbonise, decarbonise, decarbonise. So spending money on this untested, untried technology, and isn't that a waste?
Well, this is what other climate scientists say, and they have done this review in a journal called Frontiers of Science, and they've been very critical of the money that could be spent on pursuing what they see as a false promise that you can fix the Arctic, fix the Antarctic with technology. They believe you should maintain your focus on reducing carbon, because they say that is the cause of climate change. Yeah. That is how you actually fix it. Reduce the emissions as fast as you can, as close as possible to zero, and you're going to stabilise the climate. And all effort should be put there. Anything else is a distraction. Now, those who are in favour of climate repair say, well, you can do both. That from the trajectory of reducing carbon emissions now, you're still potentially going to reach a tipping point in the Arctic and the Antarctic. And that might, even if you do reach net zero at some point, it may already be too late for the ice.
But I suppose the obvious counter-argument is there's a finite amount of money around to be spent on sorting out the issue of climate change. But more than that, there is a finite amount of interest, it would appear, on the part of our world leaders.
Yeah, and the scientists aren't wavering on the need to reach net zero as fast as possible. It is the politicians who have to bring their electorates with them that are finding it very, very difficult, more so in some parts of the world than in others. And that's why when they all get together for these big climate conferences, and there is another one coming up later this autumn in Brazil, and you can be sure that they're not going to make any meaningful progress. And that is the challenge. In many ways, this isn't a scientific challenge. It is also a political challenge in reaching net zero and convincing people that the money they spend on reducing carbon now is actually going to save them money in the long run, because the consequences of climate change make extreme weather much more likely, and all other aspects that make it actually better value for money to spend money on reducing emissions now.
What do you personally make of this technology?
As one scientist told me that, what we're doing now is going to be the legacy. Future generations will have to deal with it. And if you haven't explored now what you might do, then you really aren't giving them the tools that they might need to bring in very, very quickly. If that ice really does suddenly go, if we reach that tipping point with really consequential effects on the rest of the planet.
But in terms of the decarbonising of our economies and indeed of the world, how do we do that largely here in the UK?
So a lot of it, the primary focus has been on wind and solar, decarbonising our electricity. And the UK has got a really good story to tell on that. It is leading the world. But we were the start of the Industrial Revolution. If you don't take a lead, then nobody else will follow. And that is, in many ways, the political argument for the UK maintaining its leadership in these climate negotiations. But that aside, if you start decarbonising electricity, everything else must follow. So then you bring in electric cars, you reduce the use of gas to heat homes, and that's the way you start to make differences. But it is big challenges. The easy stuff has really been done out of sight, out of mind in many ways. But it is this next stage. We're encouraging behaviour change from members of the public that is more of a challenge. And that's probably why the political dialogue is slowing down, even though the scientific community would say we need to speed up.
You've been to both the North and South Poles. I've not been lucky enough to visit either. Just describe the places to me.
They're very different. So the Arctic is an ocean covered by ice, surrounded by land, like Greenland. The Antarctic is a continent surrounded by ice. It is a surreal place. It is largely covered, it is white, clearly, but it means that it is a white desert. There are no reference points that you and I would have here. There's very difficult to understand scale. So I remember when we were going down to Antarctica, and I was with a scientist on board a ship, the research ship that the British Antarctic Survey has. And he said, well, how high do you think that mountain is over there? And how far away do you think it was? In fact, it was 50 miles away, but the air is so clear, it looked like it was just across the water, very close. And it was 3 times the height of our highest mountain here in the UK, but it looked puny. There is no scale to judge things against.
Do you think we've got enough connection to the poles, to the North and the South Pole, that it's not just a bit too out of sight, out of mind compared to other environmental issues?
Very much so. And I think that's a really important point, that people do see it as quite far away. In fact, the Arctic is actually in our backyard, because what's happening in the Arctic has an effect on the jet stream that comes across the Atlantic and affects our weather. So you can expect more extreme weather as the Arctic warms. That jet stream will speed up, it will go into weird loops, we'll get prolonged drought, prolonged flood, all these other things that we're beginning to see now. And that is the danger, that if we don't act fast enough and stop this warming in the Arctic, we're going to see more extreme weather in the future.
Thanks, Thomas. And if you want to watch Thomas's full report, that's available now on the Sky News app. We're back again tomorrow.